This question we have already solved, but there is one more easier method to solve this question. Let us see that method also. For each a element of real number, define a polynomial in terms of z. Instead of x, we have a variable z, and polynomial a means for each value of a real number, we will get distinct quadratic equations, distinct polynomials. See, p of a equal to z square plus 2e raised to a minus e raised to a z plus e raised to a minus e raised to a. Which of the following is true? We need to find. P of a has real root if a value is less than minus 1. P of a has only non-real root, non-real complex root for all a element of R. We need to check what kind of roots which it has. The roots of the quadratic equation depends on the value, discriminant value d equal to b square minus 4ac. If b square minus 4a is positive, means there are two distinct roots. If it is equal to 0, means there are unique roots, both roots are same. And if it is negative, means there is only complex root. So what is the value of b square minus 4ac here? B square minus 4ac, what is b square? B square is the quotient of the linear term, which is equal to, b is the quotient of the linear term, which is equal to d equal to b square equal to 2e raised to a minus e raised to a, the whole square, minus 4 into a value is the quotient of the square degree, second degree term, which is equal to 1 here, and c value is the constant term, which is equal to e raised to a minus e raised to a. Now we can take, see, this 2 we can take it outside as 2 square, it will become 4. So our d value will be d equal to 4 e raised to a minus e raised to a the whole square minus 4 e raised to a minus e raised to a. Now we can take 4 e raised to a minus e raised to a common from both the term. Our final value will be, this is square term, this is twice, this value is 2 times. So we can take one of the value outside, 4 has taken out, so there will be e raised to a minus e raised to a minus 1. Now we know that exponent function will be always positive. E raised to x graph will be, see, e raised to x graph will be this one, which means y equal to e raised to x. Whatever the value of x you are putting, whatever the power, if the base is e, the function will always give a positive value. 4 is positive, this is positive, which means d value completely depends on this term. We need to find whether this term is positive, negative or 0. If this term is positive, means d is positive, two distinct real roots. If this term is negative, means two roots are complex. And if this term is 0, means the entire d value will become 0, which means it only has, the roots are same. Now we can check, it depends on this term only, we can check, no need to check for the entire term. If this term is positive, negative, 0, that depends the nature of the roots. Now we have our d value, we can check the sign of this quantity, e raised to a minus e raised to a minus 1. This is not the power, this term. Now if, what is the graph of e raised to x graph? E raised to x graph will be this one. So e raised to some power will be, this is the graph. Now what is the value of e raised to 0? E raised to 0 is 1. See, if this value is greater than 1, then only this quantity will become positive. See, if this value greater than 1 means e raised to a value greater than 0. Sorry, if this value is greater than 0, if this value a minus e raised to a is greater than 0, then it will be, if it is equal to 0, it will be 0. So it should be equal to 0 or greater than 0, then only it will have real root. Now we can check, is this value is equal to 0 or less than 0 or greater than 0. If it is less than 0, means this value will be e raised to some power. If the if e raised to x, e raised to some power, if that x is less than 0, means the value will be, magnitude will be less than 1, and this entire quantity will change to negative. But e raised to x doesn't become negative. Now we can check. For that we need to find, is a minus e raised to a, the power is greater than 0 or less than 0 or positive or equal to 0, which means this quantity. In order to compare these things, we need to draw a graph. Better to draw a graph. We can show it graphically. See, ya minus e raised to a. Two functions are subtracted. So what is the function? F of x equal to y equal to a. What is a? A is any real number. So this will be a and this will be y. Instead of x we have a. That's the difference. If you have any confusion, you can substitute. Instead of a, you can substitute a. X instead of a, you can substitute x. See, what is the graph? Y equal to a graph is here, and y equal to e raised to x graph will be like this. It will be an increasing function, which means see, e raised to a is always greater than a. E raised to a is always greater than a. Or you can still find the value of this quantity if instead of a, any real number minus e raised to any real number. So you can draw y equal to x graph, this graph, and what is e raised to a? E raised to x graph, this will be this graph. See, it is clear that e raised to x is greater than x. E raised to x is always greater than x. Or you can say e raised to a is always greater than a. E raised to a is always greater than a for any real number a. Which means a minus e raised to a is less than 0. It is negative. Which means this power is negative. Which means e raised to a negative power minus e raised to a negative power minus 1. E raised to a negative power means what is e raised to a negative power? E raised to 0 is 1. E raised to negative power will be less than 1. Which means a value less than 1. A value less than 1 minus 1 will be a negative number. A value less than 1 minus 1 is a negative number. Which means this d value, this term determine the sign of d. See, this term define the sign of d. If this term is negative means our d is negative, which means it only has complex root, non-real complex root on all a element of real number.